Hello and welcome to today's topic of electric current. Our learning objectives are to describe what current is and the conditions needed for it to flow, compare the current in different parts of a closed loop circuit, recall the use of relationships between the quantity of charge, current and time, and describe how to measure current. I'd like you to start by drawing a circuit diagram in your books. Use about half a page and you can pause the video while you get that done. Your diagram should look something like this, with a cell, a switch and a bulb connected in series. Your diagram may have more than one cell, making it a battery, and that's also absolutely fine. We now have a quick practical, and you're welcome to take part in this yourself. All you'll need is 2 pencils sharpened at both ends, a 9-volt battery, a small piece of card with 2 holes in it, and a glass of water. The first thing that you need to do is put the 2 pencils into the holes in the card, as you see here. And then place the pencils into the water. Now place the 9-volt battery onto the ends of the pencils. You should be able to see bubbles being produced from the ends of the pencils, and if you remove the battery, the bubbles will stop being produced. Now I'd like you to pause the video here and think about what you've just seen, and then share your thoughts in the Google document on Google Classroom. Electric current is the rate of flow of charge. That's an important definition and you may want to copy that down. In metal wires, the charged particle that flows is the electron, and it moves from the outer shells of each atom to the next atom and the next atom, as we can see in the diagram. Individual electrons have a very small charge, so to produce significant charges we need the movement of large numbers of electrons. In order for electric current to flow, you need 2 things. The first is a cell or some other form of power supply, and the second is that the circuit must be a completed loop. Please remember these 2 key points because they do come up in exams. Finally, if we have a single closed loop or a series circuit, then the current at every point must be the same because the same number of electrons pass each point. To measure electric current, we use an ammeter, and that ammeter needs to be connected in series with the component we're investigating. Whenever we talk about conventional electric current, we're always talking about the movement of current from positive to negative. Now, this is quite confusing because electrons are actually negatively charged, so will be moved away from the negative charge and attracted towards the positive charge, so they move in the opposite direction to conventional current. We measure electric current in amps, and we use the symbol of I for intensity when we're talking about current. Electric charge is measured in the coulomb, and 1 coulomb is equal to the charge flowing in 1 second when the current is 1 amp. The symbol for the charge is the letter Q. You need to recall and apply the following equation for calculating charge. Charge flow is equal to current times time. Remember that time will be in seconds. If we had, for example, 15 amps flowing for 30 seconds, we could calculate the charge by timesing 15 by 30, giving us an answer of 450 coulombs. If we need to rearrange the equation, we can use this equation triangle with charge at the top and current times time at the bottom. All we need to do is cover up the thing that we're trying to find. For example, current would be covered up, and therefore we divide charge by time to get current. So as another example, if we have 20 coulombs of charge travelling in 5 seconds, then we divide the 20 coulombs of charge by 5 to get an answer of 4 amps for the current. I'd like you to now have a go at these 4 questions. Remember, for each of the calculations, you need to work in amps, coulombs, and seconds. So if you've got any of the values in minutes, you need to convert them into seconds first. Pause the video now while you work through these questions. Here are the answers to all 4 questions. Please mark your work, and if you've made any mistakes, go back through the question and try and work out where your mistakes were coming from. Now we're going to move on to some more advanced questions. Just watch out for question 1, where it's got the time value in 2 milliseconds. You need to use 0.002 seconds in your calculations. Have a go at these and pause the video while you're working through them. And here are the answers. Once again, mark your work, and if you've made any mistakes, go back through the video and try and identify where you're getting it wrong. Finally, we have 3 more extension questions. Now, these 3 questions are not mandatory and they are quite tricky, but if you've made short work of the earlier questions, then please do have a go. Pause the video now and see how you get on. And here are your answers. Well done to anyone who managed to get this far. These are not easy questions. Well, that brings us to the end of today's lesson. I hope you found it useful, and thank you for taking part.